Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam UTM Sanjungan Bangsa dan salam Malaysia Madani. Selamat datang ke hari ketiga UTM National Training Week 2025. Terima kasih kepada semua penonton yang terus setia bersama kami sepanjang program ini berlangsung. Bagi kehadiran ke program ini, pautan kehadiran akan saya kongsikan di ruangan komen dari semasa ke semasa. Jangan lupa untuk berinteraksi bersama kami. Segala soalan, pandangan atau respon amat kami alu-alukan. Dan seperti biasa, jangan lupa tekan like dan share agar lebih ramai lagi dapat terus serta bersama kami. Baiklah, tanpa melengahkan masa, izinkan saya memperkenalkan sesi utama kita pada pagi ini dengan tajuk From Data to AI, Transforming Data into Intelligence. Satu topik yang amat relevan dengan era digital hari ini. Bagaimana data yang kita boleh kumpul, boleh ditukar menjadi kecerdasan, memberi impak dalam pembuatan keputusan dan operasi harian. Dan lebih istimewa hari ini, sesi ini akan disampaikan oleh penceramah yang sangat berpengalaman dalam bidang ini, teknologis Dr. Chan Weng Hao dari pensyarah kanan dari Fakulti Komputeran Universiti Teknologi Malaysia. Dengan penuh hormat, dipersilakan Doktor untuk memulakan sesi.
Okay, terima kasih host for the introduction. Okay, so saya share slide dulu. Alright, so sebelum tu just check the sound. Is everyone listen? Okay, good. Alright, so selamat pagi dan salam sejahtera kepada semua. Alright, so basically, okay, so untuk session ni saya cuba mix lah because I punya slide ni dalam BI, so mix between English and also BM as well. Okay, so again, thanks for the host for the introduction. So my name is Chen Hao from Faculty of Computing, yes, and also at the same time attached to this UTMB data center. So today, basically, I want to talk about this data from data to AI, transforming whatever information that we have, right, data into intelligence, right. I think currently everyone should be very familiar with AI, right? Especially when the boom of ChatGPT. Okay, so when the start of ChatGPT, basically it changed how we actually search for information, how we interact, right? So maybe you found that you notice you are actually talking with your PC more than you talk with a normal person, right? Eventually, right? But I'm not commenting on that. But in this case, for this particular session here, I want to show the importance of data because it's not like we have all these very powerful models available, right? So we have from OpenAI, right, all the GPTs, right, and we have from cloud, 3.7, 4 Sonnet, Opus, right? We also have a different kind of open source model, right? So ranging from Microsoft, they have their open source model as well as Alibaba, we have their Qwen, currently in Qwen 3 and so on, right? And multi-modality of this model able to help a lot of things, right? But in this case, what I want to address, I try to address because with my limited knowledge here, but based on my experience that involved in some of the projects, right? So to show the importance of data, right? So how we use this, I mean, we're not like using this model just as is, right? So basically, we need to make sure it understand our cases, right? And then we need to feed in our data so that it may be able to respond. Let's say, like example, the hitting topic recently that everyone is working on is making a chatbot, right? So to make a general chatbot, basically it will be very less meaningful because you can just chat with GPT directly, right? No need to create a chatbot, right? The reason that we create a chatbot probably is we want to uh, provide an interface where user or other the public able to access this information necessarily from your research output, and also maybe your internal documents, or maybe your document is not publicly available, but it's open information, right? So you allow this information to be used and interact by this public, right? We can get accurate information, right? We can get proper information. So it is important for us to understand this, right? Or even if we want to build a predictive analysis, right? So we want to make a model to predict student performance, right, and so on, right? We still need very rely on the data, right? So maybe my way to address this AI, right, but in the perspective of data today. Okay, so I think this is probably one of the I would say one of the what we say a saying, right, that is quite or become more and more relevant, seems to be, right? Data is the new oil, right? I think for the past, maybe for the past 10 to 20 years, right? So we have a lot of digital transformation. Somehow is from moving from manual until we have this a lot of systems, right? So systems together with database, right? So all these databases basically collect all the information or the data from various aspects from a company, right? So basically, you have a HR database, right? And then you have a finance database, and then you might have training database as well for HR, right? So basically, you will have a lot of aspect of data about a single person or single employee in an organization, right? But how this data can be used, right? And what are the potential of this data might not be very significantly aware before the common use of AI, right? Because when AI get more and more common, of course, it also driven by the what we call the advancement on the infrastructure, right? So the PC or the laptop that you use currently is far way more powerful than maybe 10 years ago, right? So and in this case, the ability or the accessibility of all these machine learnings and also different AI technologies or AI techniques, right? So basically, it become a very accessible, right? So and then you also have a lot of I mean information boom in terms of you have a lot of information from online, right? You have a bunch of people that able to make a lot of tutorial to help you to understand faster, right? So with this, actually, to implement, right, to implement machine learning or AI techniques is quite, I would say, quite straightforward and easy to learn, right? I mean, as long as you understand the concept and you know what you want, right? This is something that we'll talk about later on, right? So when we have this, right, then the importance will back to the data, right? Not on collection of the data, but how we need to make sure this data is enough and also ready, right? Enough and ready for whatever purpose lah. Contoh kalau let's say mungkin you nak build a model supaya untuk predict student performance, right? So you need to make sure your data is ready. You have enough data to describe a student, for example, right? So at that place, it will become a very crucial for us to understand, right? Okay, so how I portray this flow. So first, we go back to the very, I mean, in this case, it is a AI related courses, right? So AI related talk. So I will still portray this in terms of artificial intelligence, right? I mean, not like a very in depth what is actually we have in all these techniques and so, but how the concepts of this AI, right? Because when we talk about AI is very big, right? It consists of a lot of aspect. So it consists of AI ethics, right? And if let's say going towards ethics, going towards to study about how what are the potential bias that happen when you deal with AI model, how you can use it responsibly, right? And also we'll go into robotics as well, right? I think that is the first impression on the public how AI works, because you can directly see how the robots able to recognize the environment, how they able to take corresponding action, right, to a certain environment or certain situation, right? And then after that, we need to know in this AI, what is exactly that directly interact? Let's say like if we want to start something, right? So the core concept that we need to know, right, is something like machine learning, right? So I mean, this is just a brief, right? Just to give an idea, not like a very in-depth things that we take a look into every single algorithm, but the relationship of it. All right. So of course, when I mention artificial intelligence, this is a very wide, right, a very big area, right? But particularly how actually the computers, right? Let's say like a computer program or you write an application, how the application actually able to learn, right? So most of the concepts are, let's say, most of the implementation are based on machine learning. Basically, this is a very important concept to have all these available algorithm for it to learn, right? So it's like how we learn stuff, right? I think to take it easier, this is just a recap. To take it easier is like how you learn things, right? So let's say if you're given a very given some example of data, right? So how you're able to understand the text, right? So let's say I've given you few documents, you read, you're able to understand, right? So and then I'll tell you this document is let's say a type A document. Let's say I just give you a random label, right? You look at the documents, you try to understand what is the special in this document, and somehow you remember, okay, this is type A. The next time, if I give you similar kind of document, you somehow have a impression that okay, this could be a type A document because it's very similar, right? You can see the way how we actually perceive information is quite I mean, basically, it is mimic how we think, right? Okay, so this is a very important concept of machine learning, right? Basically, is learn from data, right? At the same time, when we understand this, which also the pro and cons, lah, right? So the pro and cons, the pro is that okay, the more data that we're able to give, the better it able to become, right? That is theoretically that is the way, right? But the cons is that it very rely on what you give to it, right? So if you give wrong data, right, or some not quality data, right? So your data might suffer from some missing values or whatever, right? Or not able to represent because sometimes it's not like we have broken data, right? It's like we doesn't have enough data, right? So perhaps let's say for evaluating a talents in a company, so probably I need to know. I mean, demographic is the standard information, right? So what else information that we have? Let's say the training that this talents has been going through and so on, right? But that's all. So in this case, whether these two information is enough to justify a potential of a talents, right? So or whether we need more information, right? So that is also another issue, right? But what I want to bring up here is that data is very important here, right? So let's say in terms of anyone here who is familiar with data science, right? So you'll see if let's say you there is one saying that rubbish in, rubbish out. So whatever that you give to it, it will learn from that, right? So that is why data is much more important. And this is I try to portray this in this particular talk here. Okay. Unless of course you see deep learning, generative AI, these are all the standard terms that you will understand in current times, right? Basically, if you search for AI, you will know machine learning. You'll see this word. After that, you'll see deep learning. Basically, it's a part of machine learning, right? So deep learning is based on neural network and so on. And we are not going through that technicalities. Okay. But it's a part of machine learning, right? And then generative AI is a very specific groups of deep learning architecture that able to generate, right? So generative can be basically the way that how you use GPT, right? GPT Copilot, right? So from all this cloud, right? Cloudy, let's say 3.4, 3.74, Sonnet, Opus, right? All these are generative AI whereby they can generate images, right? Given by text, they can understand your text, and then from the text, they're able to generate. Okay, so this is we known as this Gen AI. Okay, so next is let's say we look at specifically because I try to make sure at least recap some of this thing here, right? So that I think it's important. I mean, based on how I go through these things here, right? So it's important at least when we have maybe we have a certain use case, and then probably you need to implement a certain AI in your work also, I mean, need to come up with some intelligent solution, right? So usually the first thing you need to look at what you want. I mean, perhaps you can look at what you want to do first, right? So if let's say you want to predict, right? So you want to predict what we call let's say student performance, right? So this is the goal that you want to achieve, right? And then to see whether feasibility or not, I think this is also one thing, right? Another thing to see whether feasible or not, right? And then how you map to the understanding of all this, because maybe in the initial stage you are the only one who started this, and you need to search all this relevant information to propose, and then you may not be the one that will do it, right? So I assume there are some cases like this, right? So it's important for us to know, let's say lah, we already know we want to build a model from our data, right? So next is to understand in machine learning, we have this supervised, unsupervised reinforcement learning, right? But majorly, I just focus in this supervised or unsupervised only, right? So let's say supervised learning basically is, let's say if you want to predict something, right? So you want to build a model to help you to do classification, right? So help you to recognize things, right? So this is on supervised. Basically, it's like you will need to have a group of data that is already maybe let's say lah, we take one example, classification of student performance, let's say lah, classification of student performance, let's say lah, it's not like the marks, but maybe A, B, C, D, E, and so on, right? Or pass or fail, right? The outcome. Okay. So in this case, you should have a group of data that already, I mean, historical data that already have the outcome, which means I have this group of people that I know they are passed, right? Eventually they will get passed. And these are the group of people that they eventually have withdrawn, right? Another group of people, a group of students, maybe is already known that they have failed the course, right? So in this case, uh, when you say you want to predict that, you should have that kind of information, right? And actually, that kind of information will help you to learn, right? It's like I will give you some example of question together with the outcome, right? So when you answer it wrongly, right? So I will try to adjust your perception, right, or your understanding about this topic or this question, right, with the right answer. The next time when you do, you will do better, right? So you will have this supervision during the learning, all right? So usually it's for us to build some predictive model, right? Those most of the time are supervised learning, okay? And then when unsupervised, basically it's just do grouping, right? So if you have bunch of data, then you want to do grouping, and then find similarities, right? So example, yeah, if let's say if I have this thing here, okay, just a detour, right? A slight detour from here, right? Example, right? I think this example lah, right? I mean, just a quick one. Okay. So basically, if let's say I give you this type of information, right? A prior information for you. Okay. So let's say on the left hand side, I give you some example, right? And then let's say I give you this example, you take a look on it, right? So my next question, maybe I ask you what is the estimate height if let's say the weight is 70, right? So what your brain start to do is that based on all this information, right? We call it given sample, right? So this data sample you will start to learn from this data sample what are the relationship, right? So the simplest one probably you will just plot a L shape. I mean plot a two-dimensional graph, right? And then you'll just plot it, and then you have a weight at your y, and then you have a height at your x axis, right? And then after that, you will just plot all these points together and start to understand what is their relationship, right? And then somehow you boleh lah agak-agak, if let's say 70, roughly dekat mana, right? You can estimate, right? So the way you estimate somehow is equivalent the way how the model is predicting, right? So I mean, you have data, you learn from the data, right? This is a given example, right? And then you learn from that, somehow you get an idea, you boleh lah agak-agak, right? Same as the right hand side, right? So if let's say if you give you just two groups of image, right? So two group of image. So you have group, let's say like I say group A, group B, right? So if I ask this question at below, right? So what is the group for the object? So basically you will know this is on group B, right? I mean tendency also group B. If let's say I don't have any proper example, right? So in this case, you somehow will understand it as a group B, right? Why? Because when you see the image, right? These are the data sample that sent to your brain, right? So you can imagine something. This is how also neural network works, right? So basically, this information has been sent to you, right? So you try to extract what are the important features here, right? So all these features you try to understand, right? So these are more bigger shapes item. I mean, for us, we understand more things, right? So we get these patterns, right? So you have these large items and so on, right? And then for the group B is probably is a more smaller items, right? Pens, clips, and so on, right? So basically, give you an idea. Okay, group A is large and rack kind of item. Group B is smaller items, right? When I give you a scissor, for example, so basically your tendency is to go towards group B, right? But if let's say currently this information I just scramble, I give you 50%, 50%, which means like I have few racks in group A, few racks in group B, right? And then you start to you start to confuse, right? So you start to confuse because both group also have the rack, both group also have smaller items, right? So when you want to estimate what is this group for the Caesar, you are start to get less confident, right? Somehow maybe group A, right? Because more sample at group A or more sample at group B, right? So you can see the accuracy of your classification is start to get down, right? So in this case, that is why information is important. I mean, data is important, right? So that is why I try to address this now. All right. This is the limitation if let's say we're doing supervised learning, right? Which means I give you outcome, right? And then you try to classify it based on whatever that you see, right? And also the limitation of the data if I scramble everything, which means like you cannot agak-agak lah, means that you cannot get a very good idea which is which, right? So it's like a 50-50. That is the worst case now. And that is the impact of the data in supervised. Okay. So let's say what is unsupervised, it will be something like, right? So what is unsupervised? It was something like let me see, something like this, right? So if I give you a bunch of things, right? So let's say a bunch of shapes here, right? So if let's say I mean, here is very obviously a lot of information that you can get. You have colors, you have shape, and so on. So roughly, you were able to somehow sort it out, right? Sort it out into you have a triangle, you have a hexagon, it's hexagon, yeah, okay. And then you have this uh, round shape and so on, right? So basically, you're able to start to sort it out, and then you're able to group it similar. I mean, based on whatever similarities that you're able to justify, right? So this is how we group, right? The same thing for unsupervised, right? So this happens in unsupervised learning as well, right? So what they do is like you can imagine every single shape here is a data point in a graph or whatever, right? So basically, every single data point will have their features, right? So how many shapes, how many sides do they have, and then what is the color, right? After that, perhaps size is not much, right? Color, shapes, right? And then from there, basically, you can somehow separate all these points, and they will find the similar groups, right? Same as how we do grouping here, right? This is unsupervised, means that it doesn't give you any idea. It doesn't give you any prior grouping. You will be the one who find this grouping out of based on whatever that you see, right? So this is unsupervised learning. Okay, so at least for the purpose that for this, right? At least if you let's say if you want to move towards AI, right? Let's say you have a project, want to do classification or want to predict something, right? You want to predict something, then you should somehow have some idea. This is on supervised learning, and you should search towards that direction, right? And then from there, you know your data must be labeled. Label means that you want to predict student performance. I assume your existing data should have student performance there, which means you have historical data, right? That you sure it is correct. You have a correct outcome. You learn from this outcome, then you will get a good model, right? And then if let's say you are working on, okay, I just have a bunch of data, let's say like, a lot of staff data, but I doesn't want to have any specific context of it. But I want to see, is there any interesting grouping of staff among, let's say, like, among academic staff for all faculty, right? Just like a bunch of staff become a bunch of data points, and it will depends on what information you use to justify a staff, right? And then every single staff will become a vector, and then from there you're able to find, okay, these are the few similar staff that, based on their information, they are very close to each other, right? So I think this is on the unsupervised way how we able to discover some interesting groupings that maybe we doesn't know prior to any work on this unsupervised learning, right? So this is help us to understand that. Okay, so to just visualize, right? So nothing technical and specific here, right? But this is the process, right? Because to understand the process, that's why we somehow try to relate back. I try to relate back the importance of the data. Okay, so if you have this, what we call data set, so usually what we do is we will split into different sets of data, right? Right. So I might have data for us to train, right? So basically, this data is for the model to learn, right? So basically, they will start to learn and then identify, is there any way that the model can separate. Let's say like you want to classify a student, you have two groups of students, let's say group A and group B, or pass or fail, just two groups, right? So basically, you will just try to see how it can have a good or generalized separate line, right? Like the one that you see at the right-hand side, that able to separate your data sample accordingly, right? And this line basically is the model, lah, right? So this line is the model, right? So it's like the way how we classify the image just now, right? Okay, so from there, they will try to get this model and then use this model on external data or testing data. So basically data that is new to this model, right? So whenever data fall to each of the site, right, either of the site, right, you will classify it accordingly, right? This is classification, okay? So I mean, algorithms there, I mean, you can use what kind of algorithm is fine, right? If you work on it specifically, right, or you are a developer, you are working on it, and then you can find a lot of algorithm there, all right? But for regression, similar, right? Just regression is a number, right? The one that I give you, I mean, just now that we go through, right, on the left-hand side, we have the height and also the weight. So basically that one is on what we call as regression, right? Simply say is it still have a outcome, right? And then from there, we are actually learning. Okay, what is the? I mean, when you agak-agak, also you are looking at something like a line, right? So if you notice, you try to plot it, and then you try to see, okay, kalau 70 agak-agak ialah berapa, right? So from there, actually you can have some idea, right? So similar to here, just I visualize it as a line. Okay, so if let's say once we train the model and then we test with the existing data that we know the outcome, and then we know how good is our model, whether it's accurate or not. All right. Okay, so you can see all this line here, right? So basically, it's affected by your data. If let's say you have a data that is very messy, right? Basically, like two classes, but based on the information that you use, right? Currently, I use X and Y only, two information, but based on information that you use, you can imagine like when the data points like two colors, they are just merged together. So basically, you cannot have a very good way to separate that. You may use either a more complex model, right? Or you may need to add more information so that you're able to separate nicely, right? At least better than you merge it. I mean, everything just kelam kabut lah at the center, right? So not able to really classify it properly. So in that case, when you have that kind of data, you're not able to get a good results, right? So your model probably just like 50-50, right? 50-50 yang paling teruk lah, right? Which mean you bagi data, they predict. So this is just by chance, right? Agak-agak lah, sangat-sangat agak-agak. Okay, so this is on regression, similar concepts, right? So on clustering, basically it's like doing grouping, right? This is what we have done just now, lah. Okay, so you can see basically all this works here is directly relate to how you define the data, right? So what information that you're gonna use, right, in your data, and I mean, before we even start to do this machine learning, right, or AI, right? So you should pay very careful attention, right, on the data that you have. I mean, at first, usually we will start with whatever data that we have, right? So, and then from there and see whatever data that we can use, right? Of course, personal identifiable this information will be just removed, right? So because that is not considered pattern, right? Because that one is specific to every single individual, right? So we need something that probably have a shared attributes between different individuals, and from there we try to find a patterns. Okay. So I mean, my point for this field is at least when you want to move towards AI, so what are the things that you can do, right? The next thing is how we need to prepare the data. Then that will be one of the key, right? So because like the one that just now, right? So if the data is not really representable, right? So contoh lah, kalau let's say orang yang fail pun dapat macam ni, I mean, let's say lah for a certain value, right? So let's say a student performance and so on, right? The student yang fail pun dia punya attribute macam ni, let's say lah attribute dia sama dengan student yang tak fail, right? Pass lah, right? So in this case, that particular information basically is useless, right? Because you doesn't, I mean, the information doesn't express any differences, right? Any patterns between two class of people, right? And then adding that, the impact of it is like your model need to consider one thing. It's like you need to study more things, and basically that topic will not out at your final exam, right? So sometimes I try to portray that, but whether it makes sense to you guys, or maybe you can put in the the chat box there, right? So usually I try to portray this in terms of let's say on final exam, right? So in every semester, everyone will I mean every student will take final exam, right? So before final exam, you'll have a lot of assessment, right? So if let's say lah, during the trial exam or whatever assessment that prior before the final exam, student may able to perform very well, right? So throughout the semester, the trial exam, they able to perform, let's say 90% and so on, right? Overall, lah, right? But when go to final exam, basically you get 60, right? So you can see the model actually able to do well in training, but not able to do well in the what we call testing final exam, right? So in this case, what they learn actually is very fit to whatever that they have in the semester, right? Certainly in final exam, I change a bit the question, right? The same thing, right? Change a bit the question, but they're not able to reapply back whatever that they learn, right? So what they learn, they doesn't somehow recognize, right? They doesn't recognize whatever that they have in the final exam. So something wrong there, right? So perhaps also it's like they have too much information to learn, right? So you have too many example to given throughout the semester, and then too many exercise to be done, right? But they perform well on every single exercise, right? So you might have let's say 10 or 20 exercise that you do throughout the semester. Everything they do well, right? Because they really go and focus on that. But certainly on final exam, you change, right? So whatever that they try to put effort there is not actually coming up in the final exam, right? So in this case also, you will have a bad performance, right? So in this case, the data is very important, right? So the data, what you intend to represent, right? The data, the sample that you want to predict. Let's say you want to predict student performance. So student, right? So what are the information that you want to represent student, right? And then finally their performance, right? You're back to a very because sometimes it's not the methods problem, right? Sometimes it's the data problem, right? I mean the data is not representable. I mean representative enough, right? So in this case, I would say data will be a very important key, right? So you need to be prepared. You need to be ready, right? For AI in here, I mentioned about for machine learning, for machine learnings and stuff. Okay. So here I just go through some of the how we prepare data. All right. So at the same time, this gives takes some from the source and also from our UTM BDC. We actually have a very comprehensive framework. We call it Adiba, right? So I think at the end, I can try to somehow introduce this, right, as well. So for anyone that having interest on this one, right, I will talk a little bit on that, right? So that is one of the key product that we have produced in BDC, right? Big Data Center UTM. All right. So I mean, in here, I was trying to just go through some of the process that you may or you may not, right, consider, right, during the I mean, before you even start machine learning, you need to that whenever you have data, you need to go through this step, right? You may not work on that's it lah. You already have all the features that you need, right? You may not create new features, right? But these are all the consideration you should go through, right? To check whether is there anything else that you can generate more from your data, right? And another one things that I doesn't cover explicitly here, right? Ialah kalau let's say kita ada data yang dalam sistem yang lain, right? I think this is also one of the situation di mana satu organization may have multiple system, right? And then sometimes you may have system yang sangat 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 dependent to each other, which means it's very relevant to another system, but the data is two separate database, alright? So benda-benda tu pun kena consider juga, right? So sama ada we have additional information that not captured in this system but another, right? So something like if let's say we have HR system, lepas tu ada lah training system, right? But currently, if let's say already have initiative to combine everything, then that is a good case, all right? But just to speak about the potential lah, risk, right? That kalau ada sistem yang silo, right, yang belum integrate lagi, tapi pegang data yang sangat berguna untuk let's say you punya use case lah. Okay, so first on this feature creation, right? So for this feature creation, basically is a process for you to create new information because some information dia capture dalam system, tapi it may not be a proper data yet, right? So I mean, usually I will use one saying that, but it's not my statement lah. But usually I will use one saying that which is data is not equal to input, right? So what we going through this is to make our data is ready and become the input for AI, right? So data usually not sometimes it's not, or maybe a lot of the time, is not directly equal to input because you will need a lot of processing, right? In some data, you need to do a lot of processing to make it ready, right? Masa dia ready, which means one step before you go for AI, that is the input data, right? So I mean, this is much more easier, right? It's not like every data you can just directly pump into the AI and then you start to works the magic, right? So the magic doesn't even come close, right? So when we have just directly plug in, right? So we need to make sure we have a proper data, right? And then from feature creation, basically we are creating a new features, right? So let's say example dekat sini ialah kalau let's say we have this employee lah, example, right? Lepas tu kita ada gender dan ada date. Contoh lah, di sini contoh mungkin date tu play a very important role. Di mana you may need to see is there any relationship between the specific day, right? And also let's say specific month, right? So in this case, we can also create, which means basically you extract lah, right? So daripada satu date tu mungkin you extract jadi 3 separate columns, right? Satu column untuk day, satu column untuk month, satu column untuk year, right? So in this case, you need to see in your data whether do you have any information that you can somehow generate based on the data set yang sedia ada, right? Because data set usually ikut system. Kalau let's say consider this thing come from system, dia akan ikut system, right? So dalam system masa you save the employee code, you save the gender, you save the date dah sahaja, right? So I mean usually system dia tak akan save like day, month, year macam tu, right? But when we want to use for AI, maybe that is important. Then you need to create a new one, right? So that is one thing, right? Another one, contoh kalau let's say dataset kita ada banyak kan. So dataset example, we have a lot of dataset. I mean, information of categorical information. So basically, benda macam group, right? So country, contoh lah, right? Degree, contoh dekat sini, degree and so on, right? Gender, right? That is the most common categorical that you will find in a lot of system, right? So macam mana kita nak represent, right? So represent information ni sebagai benda yang boleh dibaca oleh machine learning ataupun AI lah, right? So you need to know, for computers, they're not able to understand word as how we understand, right? So basically, our brain is quite comprehensive and also quite complex, right? So we can understand text directly to the meaning, and I give you multiple text, you can also understand or which sentence is actually similar, right? You can get this relationship together, right? So all these things, how this is also how LLM start to behave, and then of course their good is they're able to read like how many hundred thousands or how many billions of sentences at one time, right? We cannot, right? So in terms of scaling, then maybe we have the limitation there. But by default, our way of classification or our way of understanding to transform all this information to compare this information is very good, right? But in here, this is a place where we need to prepare, right? So adalah proses ni untuk encode, right? So supaya semua categorical data ni dijadikan sebagai numerical, right? Numerical, right? So of course, the numbers represent here will not be a true number, meaning that you cannot like satu tambah kosong, right? It's not like satu ialah besar, kosong ialah kecil, and so on. It's more like still grouping, but we represent it in a numerical form. Okay, so ada beberapa jenis encoding lah, right? So di sini I just show example of the label encoding, right? Contoh label encoding yang kita, it basically is like to represent all your unique value into numbers, right? Contoh kalau let's say you have male or female, right? So usually female will get 0, male will get 1 because alphabetical, right? Kalau let's say saya tak consider any specific order, right? Alphabetical saja, right? So male and female akan dapat kosong lah because F dulu, right? Baru M. Okay, so that is label. And then the next one is one hot, right? Contoh lah dekat sini ialah kalau let's say you ada 10 unique item, right? So dia akan tukarkan jadi 10 kolom yang baru, right? So basically setiap satu kolom dia macam tanya balik soalan lah. Is it a dog? Is it a cat? Is it a sheep? Right? So it will become like if let's say it is a dog, and then you have 1 at the column of the dog, and then the rest akan jadi 0, right? So ini ialah one hot. Right, so sama dia actually tukarkan benda ni jadi numerical, cuma the way how they transform is different. Okay, so di sini I think I will not say a one size fit all, right? So but salah satu limitation contohlah dekat left hand side ni ialah more to kalau let's say you have a lot of unique value, right? So dia akan sometimes the what we call the model akan mistakenly ingat 5 ialah besar, right? So, I mean, kalau let's say you dapat, let's say a master ialah, let's say for master ialah 4 kan, right? So dia akan ingat 4 ni ialah lagi besar daripada diploma, but it happen to be yes, right? Okay, but if let's say when you have this thing of a order, right? It happened to be this one is in alphabetical order, but you have a different alphabetical order, right? So the number might give a wrong impression. Dia ingat number ni lagi besar lagi bagus, right? So that is a risk there, right? So I would say, usually the way that how I involve in this one is like you may need to try both of it, right? But usually if you have kalau let's say variable tu dia memang ada sense of order, meaning that okay, a certain, let's say like LMS, right? Large, medium, small, right? So dia memang ada sense of difference, right? Ada order tu, so you may use label encoding. I think that is fine, right? Tapi mungkin you tak boleh guna alphabetical lah, you kena guna specific, right? Specific L ialah berapa, M ialah berapa, S ialah berapa. right? Kalau tak, S akan dapat value yang besar because S kat belakang kan. So same as also one hot encoding. Okay. The next thing here, ini ialah lagi penting kalau let's say untuk current time because current time actually data yang paling banyak sekali ialah textual, right? Unstructured, right? I mean text lah, right? I doesn't include that video, sound, that one is another one. All right, so I just talking about text, right? So dari sini how we convert all these text, right? Like I say, human we can understand it directly, right? But to make it represented properly in let's say computers, right, or in algorithms or in any of the AI methods. So we need to make sure all these are properly encoded, right? So there are a lot of different encoding, right? So sometimes you will see the terms, right? Kadang-kadang dia akan refer to word embedding, right? So in some case you can understand it as equivalent, right? But of course, definition-wise, they may have some different definition, right? But what ultimate goal dekat sini ialah untuk kita representkan a certain text punya information, text punya data, text tu lah, dalam satu vector, right? So a vector is, which means numerical representation of the entire text, right? And then we have a lot of different kind. We have document vectorization, right? So basically, I can represent the entire document, right? Let's say using this count of words, existence of words, right? And then kalau let's say sentence ni ada words ni, dia akan dapat satu lah. Yang tak ada words tu, dia akan dapat kosong, right? One hot encoding sama dengan tadi punya, right? So lebih kurang sama in this case. And then we will have also index-based encoding, right? So index-based ialah setiap satu text tu dia akan bagi index, right? Which means the first word exists, right? And then the second word is one and so on, right? Dia akan bagi index tu. So the number of words in the document, right? Lepas tu yang paling I would say yang paling effective, not say paling effective lah. I would say a more effective one would be word embedding, right? So word embedding ataupun embed using large language model, right? So some of the embedding model, open source embedding model, kita boleh guna model-model tu yang telah train on a large amount of text untuk tolong kita convertkan, right, text data ni kepada vectors, right? So of course, good vectors, good embedding, what does it mean? Means that they masih boleh maintain relationship of words and words, right, between words, right? And then boleh maintain semantic meaning tu, macam meaning of the words lah, meaning of the sentences tu, right? Even dah convert jadi numbers, alright? So we have that, right? So these are a few that you need to consider, especially when you deal with text, right? Another one yang standard selalunya ialah on missing value, right? So sama ada we have missing value because kadang-kadang sistem kan kita guna, lepas tu dia tak semestinya semua field is some field may be optional, right? So when it's optional and it doesn't have default value, then you have missing, right? So in this case, we are not discussing more on how we design system lah, right? But this will be the potential risk ataupun potential behavior of the data that may exist if let's say your data is extracted from the system, right? And then untuk dealing with missing value dia ada banyak jenis lah, right? Sama ada kita delete it directly, right? Ataupun kita impute. So when we impute, ialah kita somehow agak-agakkan value tu, right? Dan fill in the blank, right? Cuma selalunya fill in the blank tu, just directly impute based on mean, mode, median ke, right? So this one is very, they will also have some risk, whether it is make sense for you to impute this value, that's one. How you impute, whether it is make sense or not, right? And then whether you need to filter dulu, right? Contoh kalau let's say you punya data tu ada dua gender, right? And then dua gender lepas tu ada beberapa department, right? So when you have missing value, whether you need to based on everyone and then calculate the mean, or maybe the mean is different by department. So kalau missing value tu dekat department A, you kena somehow get the mean of orang yang dekat department A sajalah, because when you know setiap satu department may have different mean, right? So you tak boleh guna yang mean yang overall, right? Dia akan macam lari sikit lah. The way that your assumption may not stand very strong, right? Another one, kalau let's say we use a more advanced one, we can use prediction model lah. So basically, it's like we somehow use the data, and then the missing value become a target, and then we train machine learning model ataupun prediction model untuk predictkan apa value yang perlu ada dekat missing value punya spot tu lah. Alright. In this case, technicalities will rise, right? You have higher technicalities, but it may be able to predict much well because it try to learn the patterns from your data that yang ada value tu. Alright. And then sama buat KNN imputation. So basically is I tengok neighbor lah. KNN selalunya dia senang ialah macam mana saya tahu group saya apa, I tengok I punya neighbor. So kalau let's say K tu ialah 3, I tengoklah 3 neighbor saya. So kalau 3 neighbor saya, majority dia ialah group A. So saya akan berada dalam group A lah. Right. So this is on KNN based on similarities. Right. So kalau let's say data point ni somehow ada missing value ni, dia akan tengoklah yang paling dekat dengan dia, right? Apa value yang ada. So dia ambil lah. I mean you can have maybe the average of that and max of that and so on. Right? That one nanti lah, right? But the concept of KN itu saja lah. Okay. So dealing with this, and then we also need to consider about the outliers, right? So outliers tu kadang-kadang dia akan affect juga, right? So macam mana dia affect? I mean that's why I somehow give you some idea on the what we call classification, all those things, right? So contoh kalau let's say ada outliers, suddenly semua cantik. Lepas tu ada beberapa yang dia lari dekat the next class tu, right? Dia akan they will try to give wrong information or somehow affect the model creation, right? Means that the model when created, it will influence by the outlier because I also need to consider the outliers, right? When finding the patterns or finding the model, right? So in that case, because outliers means that it is just a special case. It's not the usual case that happen in most of the data, right? So in this case, but when you use that to train, somehow they affect the model. So the model assume benda ni ialah biasa lah, right? So tendency dia macam akan lari sikit, right? So in this case, outliers dia punya impact tu. So it depends on how far is the outliers as well, right? So di sini first, usually we need to detect first, right? Some other we have a very significant outliers. I mean, very what we say, what are the term? There is a mild outliers or very serious kind of outliers, right? Which mean the magnitude, right? And then from there, basically these are the methods that for us to filtering, I mean, at least detect whether ada atau tidak, right? And then after that, we were able to do on treating these outliers. Some other we delete all this observation, right? So sometimes delete is not an option because okay, when we say data is data is important, right? Another aspect when we say data is important because we have very limited data, right? So every single sample actually play a very important role, right? So sometimes it's more difficult for you to throw the entire sample, right? So in that case, maybe you need to decide whether you need to do some transformation or you need to consider throwing the column instead, right? Right? Because data tu penting. Dia macam instead of saya buang data student ni as one of the example for my machine learning to learn, right? Mungkin information ni sahajalah yang ada outliers ni yang saya buang. Tapi information lain masih ada. Data student ni masih ada. Right? This as the sample is still there, right? But maybe I just throw the information. Maybe it's too much outliers, right? And this one also you need to measure, right? So supaya tengok is that you have any special case that you would affect your model lah. All right. And then lastly is looking at this quality, because in terms of I mean this one usually kalau let's say dalam Adiba we are providing information and also guides how to ensure the data is quality, or ensure the data quality is covered, right, means that all achieve a certain level, right? So in terms of consistency, in terms of accuracy, in terms of completeness, auditability, right? Orderliness, right? Uniqueness, timeliness, right? So this is I think this would be something that is a more quality or data management level, right? But usually these are something that is quite important. I mean, when we talk about just now what we talk is more to if we have static data, right? Static data, this is what we need to check, right? But moving forward, if let's say in terms of organization level, right? If we let's say we're able to control at the very first, right? Of course, it will be much more organized at the end, right? And that is also what Adibas is trying to address, right? So later on, I'll inform. I mean, just talk a little bit on that, right? But nonetheless, this is the quality attributes, okay, that should consider, right, to make sure or at least the data is ready for any analytics. You may not do machine learning. You may not do until predictive, right? You may just do until um, diagnostic or descriptive only, right? But when you have this ready, it will be much more easier for you to move forward. Okay, and that is what I mentioned just now, lah. Right. So basically, we are trying. I mean, in terms of working on this level of analytics, right? So it depends on the needs, right? So usually descriptive will be very familiar to everyone here, right? So basically you have data, you do reporting, right? Just report whatever that is happened, right? Whatever that you see, right? What you see is what you get, right? And then try to give different perspective by changing different way of visualization, right? But it won't tell you much information because it will just represent what has happened previously, right? So let's say example of your student performance for the last few semester, right? How many fail, how many pass, and then for every single program, how many pass and fails and so on, right? I mean, when I say this, is more to just report back, right, individually, right? So without any comparison, right? Because when you start to do comparison, means that when you try to compare I mean, merge these metrics into a comparative display, right? So perhaps you can create a quadrant, right? So from the quadrant, you may have different measurement, and then from there, you may also able to see. I mean, maybe certain performance of a certain student, right, is more I mean, different behavior of student or different behavior of course or different behavior of programs, right? Different level, right? So when you have comparison, you're able to start to diagnosing the why, right? The reason that happens or something that more than you just know, okay, this is what we have, right? So when you have this comparison kind of analysis, then you start to give you some diagnostic value, right? So you can diagnose why, what are the problematic group of student or what is the problematic, I would say problematic programs, right? What are the problematic departments and so on, right? If we have this comparative kind of way, right? Usually, I mean, one of the way you can think of is something like a quadrant, right? To map into the quadrant and then it's something like whether we are going towards high difficulty, high value, something like this on this one, right? So how we understand this, right? And position, and then we can try to understand more. Another one, if let's say we go forward, right? So forward is like, okay, we have enough data that we able to use it to predict whether how good or what is the potential outcome of this student at the end of the semester, right? But in this case, you need to assume data is enough lah. All right, so we are not talking about the data, right? But when data is enough, and then you go much more forward, and then you make a predictive analysis to predict student performance, right? So you can have one model to always help you to monitor, right? And then basically we are answering this question: what is likely to happen, right? So giving you something, some foresight, right? Meaning that uh, you just learn about whatever that happens, right? And then predicting the future. Lah. Oh, this is a very, very bombastic. Lah, huh? Sounds bombastic, right? So learn from the history and predicting the future. Okay. But simply say it's like predicting the outcome. Lah. right? The more applicable one, right? So if let's say on this you're able to have a good prediction model, right? So you can somehow integrate with much more others information, right? So let's say you're able to predict student performance already, right? And then you somehow know what is the important information that able to help you predict it correctly. Let's say, okay, for me able to predict it correctly, maybe I need to look at their learning times and so on. These are the features, right? So imagine you can have these features, right? Something that you can tune, right? Right, something that you can tune. So which means like let's say for this student, current status is like this, right? You will predicted it as, I mean, based on existing, you predicted it as you would highly have the risk of fail, right? So what are the correct, or not say correct, what are the values for all these parameters, right? Supaya student ni dia punya prediction result able to back to pass, right? So something like you have something to tune, right? You have something to adjust, right? But in this case, of course, the system will try to adjust for you what is the best of value or best combination of value supaya student tu akan balik kepada outcome of pass. Let's say based on you punya prediction model, right? So integrate all this, able to give you some prescription, right? So basically, it's like it tell you what to do, right? So it tell you what to do. So what you need to do on this few aspect supaya value, I mean value nanti ataupun result nanti akan go to better, right? This is one of the example lah. Of course, it's not limited to this, right? But the point is how we can optimize. That is the main question here, right? Usually at up there, it will give you much more value, right? So usually dekat sini it will be much more towards high management, top management, how they makes a decision, right? Data-driven decision, right? Supaya, I mean, of course, ada data to support, and then this will be the suggestion, right? To support the decision itself. Okay, so this one is on prescriptive. I think currently if you search further, I think they have few more types, right? Above there, right? So you can see the more above it goes, and then the more value that you're able to get. Okay. Okay, so at least on the previous one is more to give you an idea on uh, preparing the data, right? Preparing the data, and also what are the ways that you need to consider, right? I think sometimes consideration will be some a term that I will use, right? It's not like you must perform something on that one, but you need to consider, because sometimes data that we use is from your system. Maybe you are more understand because you know your system already cater for this. It's not possible to have missing value, right? So if you have that, then probably you understand. Okay, you don't need to do, right? You have to consider that already, right? Because if let's say data is getting from external sources and so, right, of course we will need to do all this, right? Just to check, right? So usually the terms that I use will be consideration. Okay. So now we shift a little bit, right? So let's say we have data. Just now when we have data, how we can use it for machine learning, right? So what are preparations and so on. So if let's say in this case, after I go through this, I'll show you some of the demonstration, right? So if let's say another aspect, how we can use this data if let's say we want to go towards AI also, but the perspective of conversational intelligence, right? I mean, conversational intelligence sounds very technical, right? Or very specific, right? But in this case, basically, is how we can use our data and integrate with a large language model, right? I think because this currently you have access, I mean, ability to access on accessibility of all these LLM is much more uh, higher, right? So you can get your hand or interact with any of the LLM, even locally, right? Okay. So in this case, to explain about this, right? So back to this, how it will also back to this how we prepare this information, right? So just like if you remember how we let's say encode with the data that something like text, right? So usually for text data we need to encode it right, into vectors, right? So this is just a recap on this, right? So basically, it's very straightforward. If let's say we human, we see the text directly, we know lah, kita tahu lah. So let's say the first sentence and second sentence basically are referring to the very similar thing, right? And then cuma kalau let's say third sentence relatively ialah beza sikit lah, right? So kalau kita human, kita tengok, I mean, is straight away understandable, right? But for machine, basically, we will have a way to convert it, right? So of course, traditional way, we have this conversion, I mean, kind of a one-hot encoding kind of way, right? So basically is to convert everything, the existence of words in every sentence into just numerical. That's all. Dia tak ada meaning like macam how probable of light coming after I, how the next word, probability of the next word coming after the light, and so on. Dia tak ada that kind of semantic meaning, right? So dia tak ada meaning sangat lah, basically it's a count, right? So every single words dia akan nampak macam individual, right? Tak ada kaitan langsung, right? But of course, in this case, it's not the case. I mean, when we talk about language, but I'm not expert in language, so of course, language expert will have a more proper justification on this lah. All right, but what I mean is that you will have this to maintain this exact or try to maintain as much as possible the meaning of this text. Usually we can use modern embedding methods, right? Something like word-to-vex, sentence transformer, whatever pre-trained model that we have, because all these pre-trained model, basically they have gone through a lot of text data already, have trained a lot of text data. So it's like I give you a book, right? If like I give you a book and then you just read the entire book, and then after that, throughout this process, you already try to understand based on this book that you have read, right? So whenever we have these words or this few phrase, the next phrase or next word will be what, right? So basically you have an idea, the relationship of all these words based on this book, right? But we're talking about one book, right? But all these big models, basically you can assume it to read thousands of books and so on, right? They have been trained with a lot of data. So from there, the relationship of every single words is much more intense, right? Condensed, right? So you're able to represent it nicely. Okay. So this is a very important because how LM understand, right? So basically it's like convert everything you ask actually behind, they will convert it to this and then try to understand what do you mean. And then from there, they will start to generate back the corresponding response, right? Okay. But still, on the data side lah. Okay. So in this case, I will use an example of a chatbot. I mean, contohlah, kalau let's say kita ada data, what can we use this data if we going towards the direction of conversational intelligence? Means that mungkin kita nak build some AI-based model, not say AI-based model, AI-based chatbot, right? So a chatbot yang intelligent, dia boleh access let's say lah. I mean, we do have a project working on AI-driven environment that we have chatbot that able to access, right, system level informations and so on, right? Okay, so comparing with rule-based, right? So basically rule-based, I would just refer it to more hard-coded kind of way, right? Or more restricted way, meaning that they may need to be checked for certain keywords, right? Certain keywords or certain patterns, right? So in this case, out of the box kind of question will be very difficult, right? So sometimes you will see some chatbot, if you try to ask natural language, right? So they might not understand because they are restricted to a certain perspective, right? So usually this will be much more straightforward kind of chatbot. Means that you're simple, repetitive, right? Very straightforward kind of FAQ, but it's not you are not targeted to let the user to ask too much, right? Or too complex, handle too complex query, right? But AI based, I think good is that, right? When we able to integrate LLMs further, right? And then not only just integrate, but inside you have a lot of process, right? How we orchestrate, right? LLM orchestration, how we orchestrate the flow, right? how the model able to follow this flow to understand your question and respond back to you. That is the key things, right? But still, you still rely on data lah. Later I will show you, right? And then able to understand the natural language. This is a good one. And then able to learn from interaction, right, to improve over time, right? So you are able to set up memory and for that to understand. Let's say this is user based, right? So technically, we are not like heavily retrain back the entire LM, right? Let's say the LM, I mean the model is we refer to is LM, right? To retrain that is a lot of cost and so on to consider, right? But learn from interaction means that use memory and also these memory components and so, right, can able to help this and remember and improve, which means maybe you already tell this model or this chatbot what not to do and so on, right? I mean the way that you interact with ChatGPT, similar, right? And then in this case, you're able to handle complex unstructured conversation, right? So even some good model, you can handle multiple language, right? You can ask in different language, knowledge base in English. They can also regenerate back in the corresponding language, right? It's good, right? And also personalization. I think this is a lot of the things that a lot of people start to do personalization, right? I mean, in terms of leverage all this existing model, right? And use into, I mean, personalize it, right? Feed it to the system, able to get personal, not saying get personal info, but able to access, right? Personal, a more individual information, right? For this particular person, right? And then able to produce a targeted response. Okay, so it best suited for complex scenario and so on. Okay, so I mean, this is just on to understand. I mean, when we say we want to prepare this data and then want to use LLM, right? So in some case, we need to understand or have expectation. We don't expect too much, right? This is same as human as well, right? So kita kena tahu apa yang dia boleh buat and then apa potential risk yang dia ada, right? So in fact, you have this limitation. I think limitation lah, right? Atas tu basically is standard, right? Versatility, automation, and accessibility, right? So you easy access, it's versatile, right? You can tell it to do any task, right? Tapi limitation ni yang kena take note lah. Alright, I mean this is based on the one that we have done before, right? So one of the limitation dekat sini masih lagi ialah hallucination, right? I mean depends on model guna juga, right? So the quality may be different, right? But hallucination will still exist, right? So especially when we ask something very specific, right? Specific that they doesn't have any context. Basically, they just generate based on whatever that they learn, right? So this akan ada, right? So to understand this is important also is for us to have this expectation, and when we test the chatbot example, we need to test something that we expect it to. I mean, let's say I design this chatbot with knowledge base behind, right? So sepatutnya kalau lah tanya soalan ni dia boleh jawab dengan more accurate and proper, right? Especially with up to date information yang tidak boleh dapat dekat Google ke, because updated the document, right? You have the document first hand, right? So you can test with that whether it is working or not, or it still hallucinate. Right. Of course, secondly is on the cost because untuk training running, kalau let's say we're going to until training, right? So there is a large cost lah. All right. So on this model, but usually to understand, I mean by understanding this is to look at different perspective of how we can improve. Satu ialah, I mean, improve in terms of master conversation session tu. So kita ada memory and so on. Another one is to have this fine tuning maybe, right? Smaller model, right? Supaya boleh guna dekat you punya use case. Cukup untuk use case, then it's fine, right? And of course, ethical concern, right? Another one is when we have this integration with LLM, right? I mean, ethical concern di sini ialah refer more to creating fake contents and so on. But another one maybe on security purpose, especially on sharing personal information to open chatbots and so on, right? If let's say you know the chatbot is using OpenAI, sama ada sesuai ke tak kalau let's say untuk access, right? So in this case, you will need to have a decision, right? Anything that you access a system, you should somehow use a local model, right? Or you need to do something to make sure the information, personal information is not critical, right? So maybe I think on security purpose, I mean cybersecurity expert will have this masking and also anonymization and so on, right? Supaya data yang digunakan tu masih boleh jawab, I mean digunakan untuk jawab soalan ataupun improve in terms of experience, tapi kurangkan the leak of personal info, right? So that is also another consideration lah. Okay. So, macam mana kita boleh guna data ni, right? So let's say data to AI kan. So macam mana kita boleh guna data ni supaya kita boleh let's say in this case conversational intelligence, create a chatbot. So I think one of the simplest, or one of the, I would say not say simple, one of the most straightforward way is to using this retrieval augmented generation, right? So basically it's like, I mean, if let's say working on chatbot lah, right? So if let's say you're building a chatbot, so basically chatbot ni, I think the very first place you need to understand what is the purpose of this chatbot, right? So let's say this chatbot is targeted to use internally, right? And then to ask question on whatever policies or documents that we have, and then supaya dia boleh somehow jadi a assistant di mana you tak perlu, I mean, kurangkan, right, direct reference of all these documents, because maybe in some tasks you need to refer to so many documents and then you need to come to a summary and so on and so on, right? But when your chatbot able to access this, right, this RAG concept ialah dia different sikit dengan cara kita interact with normal chatbot, right? And I mean normal chatbot, what I mean is more to like ChatGPT kind of thing, right? Right. So in terms of the way we interact with ChatGPT, basically we ask them and then they just based on whatever that they learn, they give you. Right. You have the search button, so they will search real-time info and then give back to you. Right. And then you can also upload a PDF. Right. Of course, you can upload a PDF and then ask it to you. Right. But in this case, this chatbot concept dia basic scale. Right. So I think the first major difference is the perspective of, let me see, I think I have one. The perspective of how we interact with LLM, right? So when I say macam mana kita boleh guna data untuk conversational, I mean supaya somehow lah capai conversational intelligence, right? Atas ni ialah how we use GPT, right, as a user individually. So contohlah saya ada GPT dekat tempat saya, right? So basically I interact with GPT is for my own use, right? And then I put PDF sana ialah basically is for me, right? And then I mean content tu akan directly apply to myself lah, right? So I am the user to use this and I am the user to consume this, right? Different with the concept that I mentioned just now is more to dekat sini ialah we will act as the knowledge based provider, right? So kita yang ada dokumen-dokumen tu, right? And kita nak jadikan dia digunakan sebagai knowledge base dalam satu conversational AI, for example, right? Right? And then in this case, ialah we are creating a bot supaya digunakan oleh orang lain, right? Orang ramai lah, right? So the perspective is different, right? Because maybe some of you might think, okay, I think read PDF, I can do it in ChatGPT, right? So why I need to have a rack, right? So this is a different purpose, right? So in this case, we are talking about kalau let's say kita nak establish satu untuk let's say lah untuk PTJ, salah satu PTJ kita nak buat satu chatbot supaya tak payahlah, I mean for simple question they able to simple to medium complexity kind of question, tapi jawapannya selalunya datang daripada dokumen sahaja, right? So di sini dia boleh directly interact with the user directly, right? But still intelligently refer back to the knowledge base. Dia tidak akan cakap bukan-bukan, right? So this is the purpose of this, right? Right. Okay, so we're able to create one chatbot di mana we will have this knowledge base, right? Supaya kita minimizekan hallucination, right? And then we make sure chatbot tu akan jawab dengan adanya satu basis yang proper, right? So all the time, usually I will portray this as a receptionist, right? So you have a company, you have a receptionist, right? Of course, the receptionist let's say a customer coming in, this receptionist will answer a question accordingly based on whatever company have, right? I mean, it won't like just talk nonsense about anything, right? Usually they will just refer, let's say ask certain question, this receptionist, what they do or what he or she do. So they will just refer back to the policy or whatever according to the question, and then reply back to the person, right? So this is a much more try to control and minimize, right, misinformation, right? So this is one of the way, right? Retrieval augmented generation, right? Of course, there are a lot of variant. I think this is I would say this is a core concept, right? There are a lot of variant. So some are using knowledge augmented generation, KAG, right? So some you have context augmented generation as well, right? So there are a lot of variant, but nonetheless, the main purpose of this is more towards on minimizing and then minimizing the hallucination, right? For information and maximizing a more informative kind of response. Okay, so basically we have this knowledge base, right? So I think maybe if let's say in UTM itself, some of the PTJ already having work on something on this, right? So basically you have this knowledge base where you have all this new information coming in, right? This is the place where you need to make sure the correct data, right? So the correct data, the appropriate data to be put in, right? So I mean in this case, a more high level is like filtering of the documents, meaning that what documents you should put as the knowledge base, right? So this one always link back to what is the purpose of the chatbot, right? So it's not possible like dia chatbot ni ialah digunakan oleh student. So I mean policy on staff maybe it's not like appropriate on that, right? You should need to make sure it is cover all the academic handbook, all the let's say handbook lah, and then Bendahari punya guidelines for student lah, and so on. Let's say if any, right? So need to make sure appropriate data, right? So when I say data here is usually first impression will be directly PDF documents, right? Documents, PDF, words, right? So in form of a file lah, right? Another one, a more uh, detailed information will be the access of the SQL, right? So you may have tables and so on. That one also can be included in here, right? So apa yang dia buat dekat sini, basically all this data, it will be pre-processed, right? Pre-processed, ready, and then they will do text embedding. Remember the one that tadi ada encoding lah, semua tu lah, right? So di sini sama juga, right? So apa yang I mean in RAG, what they do actually is that I will just transform all my documents into a proper into a form of vector, right? Of course, the original text masih ada lah, right? But you will have a form of vector yang representkan text ni, right? And then when they start to search, right? So contoh lah, kalau let's say ada orang tanya soalan, right? So in this case, the question will directly go to the chatbot, right? Of course, the chatbot behind the LLM, it won't like directly answer the question, right? So dia akan buat satu benda called retrieval dulu, right? So in this case, they will retrieve the data, right? So retrieve data, macam mana dia buat retrieval data? I mean, if let's say in the simple words, you punya question, tukarkan jadi vector juga, lebih kurang like this one, right? So you punya question punya vectors, compare with all the relevant all the vectors that you have in the vector database, right? So it's like what matching, tapi bukan keyword matching, the entire vectors matching, right? Ataupun vector similarity searching, right? So basically dia akan retrievekan balik all the relevant vectors, right? You can understand vector macam point lah, satu point yang dekat graph ni, right? So let's say your query is one of the point, you are retrieving all the documents yang dekat dengan you punya query, right? So di sini dia akan dapat this relevant vectors, right? Relevant vectors together with the content itself lah, right? Dan content ni akan digunakan sebagai basis, alright? So all your basis to generate back the response. Okay, response masih generate, right? Usually dia tak akan ambil satu split lah, unless you specify in the prompt ambil satu split saja, right? But usually they will still have some random generation from there, right? Tapi basis dia akan based on the content yang you retrieve daripada vector database, right? So this will be try to be as close as possible, right? Meaning that it's not like generate wildly, right? But you were able to answer accordingly, right? With a proper information. Okay. Okay, so that's why this RAG here, implementation there is quite I would say currently you can do it quite easily, right? So later I just demo it, but I'm not able to host it somewhere. So supaya you boleh try on, right? But benda ni dia boleh work locally lah. Alright. Okay, so this one also at least give you some idea. I mean, the way that kita nak guna data kita untuk achieve a conversational AI integrate with LLM supaya kita buat chatbot is beza dengan I just use the data with ChatGPT. I usually don't use personal data dengan ChatGPT lah. I mean, if using any public data with ChatGPT, that one is more on how we interact and then for our own use, right? So apa yang kita tengok is more on the bottom one. Okay. So untuk let's say lah untuk this one actually we can achieve it in a lot of way, right? So salah satu contoh um this is one of the way. This is one of the tools I would say, right? These are the tools, bukan on hands-on directly. But this is a tool di mana it actually show you the way how we can do rank, right? So I mean you can see the tools number tools you can go and search lah. All right. But this is self-hostable. Basically you can host it, right? So di sini okay, what do we mean is important for information? Because information is something like this, right? Academic handbook. So basically this one is satu contoh lah academic handbook yang saya download daripada FC punya. Alright. So dekat sini basically this is will act as one of my knowledge base, right? So this knowledge base will be referred, right, whenever the bot is actually interacting with user and so on, right? So if you see this, basically all this PDF will be automatically extract, right, on the content, right? So di sini all the content lah of the entire academic handbook, right, into different chunks, right? Kenapa nak different chunks? I mean, example lah. Kalau let's say you tanya, I mean this is a preparation of the data, right? So if let's say you tanya reception tu, right? So you tanya one soalan, right? If let's say your information is a long piece of paper, right? So what the reception do, they take a long time for he or she to trace, right? Because it's a long piece of paper, right? Everything in one piece of paper, right? So you can understand this, you will use a lot of resources, right? You may not search a proper information, right? So a much proper one is usually we will have index, right? Index or different pages, right? So you have a TOC, right? Table of content, and then from there okay, this is question regarding to one thing, right? Just search on the content page berapa, and then search on that page saja, right? So I mean in this case, just a very simple example. I mean this one will be much more easier, right? Kalau let's say everything is in a one long piece of paper, right? So this is sama. Kalau let's say dekat sini, right? So they will usually split into chunks, right? Supaya search tu lagi easy, right? Lagi straightforward lah. So setiap satu chunk ni akan represent in a vector, right? You can see there are a lot of vectors here, right? So each chunk will be converted to vectors, and then when they try to search, right? When they try do the question answer, then it will search all this, right? So example, let's say on this one, right? So this is just a simple chatbot, right? So in this case, if let's say we're working on this one, right? So this is a simple chatbot that we have all this information, right? So all this information I have put in, right? But this demo, I just use a simple store only lah. I didn't establish one proper vector database. You can do that directly in local, or you can do it in cloud, right? But this one I just use a in-memory one, right? So because it's not like a workshop, so I doesn't go in detail for this, but I show you this is doable, right? Doable, and I mean probably some of the PDJ is actually using this, right? So basically we can test with this, right? So but of course it depends on the model, right? So I'm not sure whether we have, let's see. All right. So this platform is good. Is they will give you directly how to build a chatbot, right? So I think the information I haven't checked on that one, right? But you can see, if let's say one of the example here, right? If you ask something that they're not able to find the context, right? So basically they actually controlled by this, right? So they're actually controlled by this system prompt, whereby they will ask this LLM supaya dia akan try to answer this question if let's say you're not able to find any relevance context, right? And then just don't answer ataupun maybe di sini mungkin don't answer lah because don't answer tu kadang-kadang dia nampak macam uh, harsh sangat kan. So maybe you can just say, I mean, in this case, maybe out of context kind of information, you can rephrase it so that you can please refer to a certain contact for more information also, right? That's one, right? So in this case, actually the content itself sangat penting lah. I mean, if you put the content, let's see lah. I think this handbook is probably more on program. It's not really on PSM and so on, right? So they maybe not have a lot of information here, right? But it doesn't have this PDF here. But this is the way how we actually control, right? The behavior of the bot, right? But in this case, I'll show you more detail is how the splitting works, right? Contoh kalau let's say we have let me see if I have my file academic handbook, right? So for this, okay, so let's say contoh. Okay, so basically they'll extract all these tags, right? And then I mean, this is what the preparation of the data, right? Because untuk guna tu, I mean, it's easier. Let's say we try it together, but currently we are not focusing on that, right? So let's say we are able to by sentence, right? So basically we can create different chunks, right? So in here, it will break down every single page of data into chunks, and then they will do this vectorization, right? So this is the step, right? So this is a step yang berlaku masa creating the database. Contoh, I can always see chunk satu ni ialah content apa, chunk dua ni content apa, right? So it's like you are splitting all this information into pages, right? And then the pages can be defined using a number of words, paragraph, and so on, right? And then every single chunks you will show as vectors, right? So it's like this is the vectors representation of chunk number 5, right? This is a vector representation for chunk number 2, right? So you can see everything is like converting to something that the AI able to read and able to relate back, right? So what is this about? And then what is the content that you having in your vector database, right? So this is I mean, this one is much straightforward because it's more to you have documents, right? Just you need to make sure selecting document that is readable, right? So I think one of the limitation when we do one of project with one of the agency, government agency, right, is on when we try to read the data file, right, or read the what we call documents, right? So the documents actually it doesn't return anything, right? Because the document itself is image, right? So that is another challenge whereby we need to make sure if let's say we want to build a chatbot, make sure your PDF is searchable, right? If let's say your PDF is an image-based PDF, so usually in that case, our solution is to implement OCR, right? So OCR basically is it's like the way that you use PDF, Adobe PDF, right? So you can also edit. So if let's say the page is image based, they will recognize every single character and convert it into searchable text. So once they convert it into searchable text, then you can do searching, you can do edit and so on. Right? This is the same case, right? So if let's say your data is a PDF document and then it's not readable, right? So one way is to convert every single page to image and then to read back to the read by the OCR engine, right? Convert back to text, and then the rest is the same, right? Once you have text, do embedding, one embedding, and then do for AI. Okay. So that's the process happen behind. But maybe for the personnel that more to content guardian, right? The one that you gatekeeping on the content or provide the content, right? So you need to make sure you provide relevant content, right? In terms of going towards conversational intelligence, you need to provide relevant content. You need to know. Sometimes the content maybe need to filter. Means that instead of you have all the pages, maybe you just know these few pages are more specific. I mean, should do until that level to make sure only relevant, because sometimes the entire PDF may not be very relevant, right? Only a certain part that having the core information, right? So in that case, instead of you waste a lot of resources to generate a lot of vectors that maybe will just makes the searching or makes the retrieval not effective, right? So in this case, to make it better, you can also further filter the exact information that we should put in the vector store, right? Or the knowledge base, lah, what I call. Okay. And then if let's say, I think towards the back here, what else that we can do if let's say data, we will have some, let's say, in terms of more personal data, right, or personal documents, but you still need to leverage this conversational AI, right, or LLM. So another one that actually currently is work, but maybe it's not a big scale, but a rather smaller scale, right, with but still with some cost, lah, right, which is using local, right. So I mean, this is just to give you some idea on it, right? So currently local LLM is it's not hard to use, right? And then but it's just like maybe option that you have limited resources, you may be able to use smaller model, right? But if let's say you have a much more resources, or let's say PDG have a server on that and able to run a larger model, but you can do this, right? So the advantage of this is run locally. So and it's still having all these capabilities of LLM, right? Which is some model able to understand text, some model, I mean, most model are able to understand text, but some model able to have this vision capability, right? So you can put image on it, they were able to summarize for you, right? Everything host locally, right? So especially when we have more sensitive information, something like photos and so on, right? So we can somehow use local model, right? So I mean, asterisk, you need resources, lah, right? But it's doable, right? So how we do, I mean, usually is we interact with the model that is from cloud. That is the simplest one, right? Because it's very easy, straightforward. You just need to have the API key. But of course, API key depends on model, whether some model will charge per token, right? Some also, they have this free API key that for you to use, right? So you can freely use this. I think you can search for open routers, right? I didn't put here, right? And open routers, and then you can search that. That one you have free, what you call API for you to use, right? Okay, so in this case, this is on cloud, because sometimes the issue is not like using paid or using free. The issue is whether you are eligible, or is it proper for us to query that kind of information or that kind of document into sending to a third party, right? So I think that is a consideration when we talking about a more sensitive data. Okay, and then so this is the way how you're able to works directly, right? So it's towards the end. I just I mean, consideration. This is a pro and cons now, I would say, right? I mean, towards when we say towards conversational AI, right? So I use this example um to somehow let you to see, like, okay, let's say when we have data ready, what else we can do until we get something, right? I mean, in this case, chatbot, lah, all right, in terms of implementation of chatbot. Okay, so in this case, you can see the pro and cons, right? So basically, you can able to have, I mean, in terms of privacy, in terms of offline access, because it doesn't need internet for you to work, right? Basically, they will just need a lot of RAM, right? So it depends on how you define, or how big is the model that you want to use, right? So basically, it will it will just use up your resources, right? I mean, depending on the size, and then cost effective in terms of if let's say you are using large scale, right? Let's say you have the infrastructure already, so in using local, you will just save a lot of cost on querying on the API, right? Just on that, right? But if let's say you don't have infrastructure from no until yes, in terms of infrastructure, that is not cost effective lah. All right, the cost effective I refer here is more on the query, right? And then in terms of customization, you have all the customization and control, right? Because it's on local, so you can also fine tune it if let's say you want to fine tune it with all your own data so that it's able to perform better, right? And then of course reduce latency if let's say using internally, right? Consideration of another part, right? Of course, usually my emphasis is always you need to have accordingly. I mean, have a proper consideration for everything, right? So, but in this case, consideration will be more to the computer resources, right? So the resources that you need to use, if let's say you need to have when running this local model, and then also the model updates as well. You need to have people to maintain it, right? So if let's say a certain model, when they first come, they may have a different version, right? So you need to make sure a model is updated to get the best out of it, right? And then after that, we have this technicalities, right? So in terms of managing it, you refer some technicalities, right? Which means you need some specific people to maintain it, right? To just in case, right? It doesn't work and so on. Okay. So I mean, when we go to this realm, you have a lot of things to be used, right? So assume, I mean, until this stage, assume data and everything is done. But in terms of the model itself, these are the open source model that basically available, right? So basically, you can download the entire model for you to use locally, right? So they are not from some small vendor, but they consider a big player as well, right? So they have this open source versions of models, right? So from Alibaba, from Meta, from Google, right? So there's a good, right? So example for Geometry is quite good because they're able to have vision capability, right? So you can query PDF, you can query text, you can also query image, right? And then the ability for them to understand image is quite good for a medium-sized model, all right? So when you open up this realm of LM, basically how you're able to integrate with all this, all right? And here I will just show some, I mean, same as the direction just now, right? So consider if there's a data, everything ready, going towards conversational AI, right? So these are the some of the stack that I put up together, right? Based on my limited experience, right? So on this one, so to give you some idea, like if let's say you want to integrate, right? I mean, going towards AI is I mean, let's say your road towards making this data into AI is more on conversation. These are something that you may able to explore, right? So from local hosting until the available of model that you're able to get, until the framework that you can work on. If let's say for developer, right? For non-developer, maybe not too much, but if you want to learn, yes, sir, right? So we have LangChain and transformer and so on, right? These are the important thing, right? User interface are different, depends, right? But this I put here is an example. If let's say you want to go to UI, right? In Python and so, right? But of course, in vector database, these are the important. Okay, this place is the core. Let's say like RAG, retrieval augmented generation. The important one is the knowledge base, right? So to store all your data, right? All your converted data, I mean, all your vector data, right? So these are some of the options that are available, like Chroma. Chroma is free, right? Elasticsearch, I think they have this local hostable version, right? But you can explore on it. Postgres is free as well, right? For the PG vector. Okay, so after that, if let's say you want to work on a chatbot to work quickly, right? So you can go for this no-code LLM application, right? So example like the Flowwise that I used just now, and also the NAN for automation, right? So you can do far more complex workflow on that, right? But that is based on no code. But still, you need to have some learning curve to understand what component needed, right? And then we have this LM tools. Yeah, this one is more like back to the individual usage, something like the way that we use ChatGPT. But these are the tools that instead of going to the browser, these are the tools that you can install in your local machine and then interact with AI models, right? So you can interact with local models as well as interact with the remote model, right? But it will more to individual use, right? But it is a kind of I would say a kind of software that you can use on that particular aspect lah. Okay, and if let's say anyone that working with I mean more to a developer, right? So everything here is actually workable in Python, right? So if let's say it doesn't see the no code application and also the LM tools, the rest of the things actually workable in Python, right? So the entire stack you can you can interact with Python, right? So I think Python would be something that if let's say from data towards AI, this road here, right? So if let's say you want to experience on it or you want to do something on it, I think Python somehow will be something that you will encounter, right? In the middle of the road or even at the start of the road. Okay. So this is just information only, right? So what Python can do, right? So we have this a lot of library support, right? So basically I would say, or depend on use case. So some use case basically end to end, right? So from the back end until the processing until front end, right? So basically you can do that. But I would not say it's the best. It's not the best performance, right? I mean, C and Java will be C++ and Java will be much more faster, or C sharp, right? Compared with Python, right? But I would say the special on this one is more on the library and the coverage of the functionalities, right? So different functionalities, if let's say in the road of preparing data, right? So you have a lot of data cleaning, exploratory data analysis means that you explore your data, right? Just to get to know more about your data, you have a lot of things that you can do in Python, right? Of course, learning this may have some learning curve, but it's actually quite easy because you also have a lot of AI assistant to help you to learn, right? But more importantly is you need to know what you want, right? What you want to achieve, what is the process that you want to do, right? And then for machine learning, if let's go to training, everything, right? So these are some of the, I mean, the straightforward stack. I would say they have a lot of others, what we say, others library as well, right? But this will be, I would say, the core that you definitely will see it, right? If you invest yourself in using this Python, right? Okay. And lastly, for things to move forward, I think let's say lah, to have this data until AI, right? So in this road of transformation of data quality will be one of the important factor, right? Data quality, data availability, right? And also, of course, data availability and also your data integration. So how integrate your data is, or whether your data is silo and so on, right? So this is again a chance to just introduce a little bit on what we have in big data center. All right. So you have this Adiba. So basically, Adiba is a very comprehensive framework where we cover end to end. So basically, we provide a very comprehensive what we call a framework, right? So for let's say organization that getting started in establishing or getting started to adopt big data analytics or getting started to adopt a different kind of analytics, right? So from end to end, we will provide a very comprehensive guidelines, right? So from how we understand about data sources, how we able to do data consolidation. So what are the consideration to do? What are the steps to do? Right? Very comprehensive guidelines for every single steps. Right? Of course, we have a lot of others information you can check through this website here. Right? So for the information of Adiba, and then how we should store our data. Right? So to store our data, we will have different forms of database that we can store. We can either store it as a warehouse, either store it as a lake, right? So they serve different purpose, right? And then how this information can be further used in provisioning, something like on analytics, right? So descriptive, diagnostic, predictive, prescriptive, right? And how we can prepare all this data, right? So we can prepare the data so that be able to store properly, able to provision properly, able to use it, right? In terms of, it depends on use case. And then to achieve this data discovery, such as we can do in terms of reporting, right? In terms of, it can be in terms of analytic dashboard, in terms of having alert and so on, right? And then we also focus or emphasize in terms of the enculturation, right? And also the impact towards all these beneficiary, right? So in terms of internal user, local industry, and so on, right? To understand the entire process here. And then we also cover the needs of data governance and also master data management. I think in some of the PTJ in UTM has also together with us to learn about this, right? So this is the example of the framework, right, of Adipa. But of course, we have much more details, right? So anyone who interested or maybe want to know more, and we also do provide professional training on Adiba as well, right? So if you have any interested on this one further, you can contact either email me or I can email to utmbdc@utm.com. All right. So I mean it's important as at least we have said it right at the start, right? So you will much more empowering the analytics and also the innovation in terms of predictive analytics and so on along the way, right? Because or else is every time as an ad hoc project, it will be quite difficult because you spend that, but still the route is not really ready, right? So you will put a lot of effort for every single project, right? Okay, so I guess this should be some perspective maybe useful to you guys. All right. And then I also try to portray this one, right? Instead of just explain about AI, but I try to use a certain use case, right? So whatever that we have, I mean, depends on different PTJ, right? So need to aware what kind of data that we have. Maybe in some case you may thinking about want to build a prediction model for a certain use case or whatever, right? Look back on the data. What data do we have? What else data do we miss, right? And then is there any data that available in other database and so on, right? So I think these are the consideration that you need to have, right? So once you have all the data, right? So prepare the data properly, right? So prepare data properly in terms of, I mean, all those managing of order value, conversion of order value to make sure it is properly represented, right? And then after that, if let's say on conversational AI, make sure the data is relevant, right? So do not include conflicting information. Let's say especially on abbreviation, right? So sometimes abbreviation may be conflicting, right? Maybe in different PTJ you will have some same abbreviation, but when you put two information together, it may confuse. But if we are aware of that, then we might have a solution in terms of designing the vector database in different vector database. So I have one database for this PTJ, another database for another PTJ, or one PTJ might have multiple database, right? I mean vector database for the chatbot, the search, and so on. Example, right? So yeah, and it's important for us to understand this, the importance of data, right? AI is just learn whatever that we feed to it, right? So basically, if we not really take attention on the data, right? So I mean, it's hard for us to expect a good performance from the whatever AI solution that we are providing or creating, right? So everything will have to back to the data, right? So that is the root. Okay, and I guess this will give you some good perspective, I hope, right? And yeah, I think back to the host ada lagi.
Doktor sekejap ya. Tengah buka ni. Okey, terima kasih Dr. Chan. Tamat sudah
Yeah.
sesi kita dalam UTM National Training Week 2025 dengan tajuk From Data to AI, Transforming Data into Intelligence. Terima kasih sekali lagi kami ucapkan kepada Dr. Chan atas perkongsian yang sangat insightful dan padat dengan ilmu. Harapnya selepas ini, data bukan sekadar angka tetapi jadi aset digital yang bantu kita semua membuat keputusan yang lebih bijak dan berimpak. Terima kasih juga kepada semua penonton yang turut serta secara langsung. Jumpa anda di sesi petang pada jam 2.30 petang di platform yang sama. Stay curious, stay data driven. Assalamualaikum semua.
Okay, thank you.